Hey, hi YouTube. I hope you all guys are doing great. From this video, we are starting a new series where we will be looking at the memory in Langchain. So in this video or in this upcoming series, we are going to see a lot about a memory in Langchain, and this is going to be a one-stop video for you to understand the whole memory concept in Langchain. Definitely there are 9 different videos, so I have divided the whole memory section into 9 videos. First one will be introduction to memory. Second one will be from second onwards the type of memory will be started, like conversation buffer memory, conversation buffer window memory, entity conversation knowledge graph memory, conversation summary memory, then conversation summary buffer memory, conversation token buffer memory, and the last one is vector store retriever memory. So I hope if you will if you are looking at this whole videos, I think this series is enough for you to understand memory in Langchain, and so that you can have a very good basics of Langchain, so that whenever in your RAG bot or wherever you are using this memory, it can be very easy and very helpful. And definitely I am going to upload all the notebooks in this GitHub repo. I will be sharing this GitHub repo in the description box. So once every video is launched, we will be pushing all the code so that you can fork it and you can use it, so that it can be very helpful for you. And definitely in the whole series, it's not only the theory series. Definitely I will deep dive into the theory, but also we will be seeing a lot of codes. For each video we will be having a different notebook, so that you can study and at the same time you can implement it, so that you can have a better understanding. So meet you in the next section where we will be seeing about the introduction to memory. Hi, in this section we are going to see the introduction to memory in Langchain. So memory is a very crucial component of conversational interfaces in LLM applications. It enables the system to refer back to information introduced earlier in the conversation, enhancing the conversational experience. Let me give you an example. You might have seen a lot of chatbots where there is a conversation pattern. So let's suppose you asked a question like, tell me the capital of Japan. Okay, then maybe the bot answers like, capital of Japan is Tokyo. Now the next question will be like you can ask like this, population question mark. Now you don't have to implicitly mention that you are asking about Japan. Definitely if the first question is about Japan, then the population should be also about Japan. Okay, so then the bot will answer with some numbers. Okay, so this is how conversation bot works, and this is because of memory, because this is already stored in the memory. That's why in the next new query we are utilizing it from the history. So at its core, a conversational system should be able to access the window of past message directly. However, a more advanced system requires a dynamic world model that is constantly updated, allowing it to maintain information about entities and their relationships. So Langchain offers a range of utilities for integrating memory into the system. These utilities can be used independently or seamlessly incorporated into a chain. It is important to note that the most memory related functionalities in Langchain are currently in beta. So they are in beta mode. This means that they are not yet considered production ready. Okay, the date in which I am making this video is 4th April 2024. Still it is in beta mode. I don't know when you are looking the video, it can be in the release mode. Okay, so this means that they are not yet considered production ready, with the exception of chat message history functionality, which is largely ready for production and integrated in the newer that LCL syntax. Okay, so first of all, let's see what is the basic functionality of a memory system. So a memory system in Langchain needs to support two fundamental actions. First one is reading and then the writing. Okay, when a chain receives initial user input, it reads from its memory system to augment these inputs. Okay, after executing its core logic, the chain then writes the input and outputs of the current to the memory. This allows the system to refer back to the information in future runs, improving its ability to maintain context and continuity in conversations. What I want to say is, let's suppose in this question only, let me give you this example. Like in chat history DB, this question will be stored. Okay, so this is where we are storing the chat history, or you can say memory. Okay, so this is already stored. This one, tell me the capital of Japan, and the AI message capital of Japan is Tokyo. This was human message, this is AI message. This is already stored. Okay, now let's suppose a new question entered like population. Okay, so in this way, first of all, the population have to read from the chat history. It has to read that what actually previously stored questions are there. So it is tell me about Japan. Now the new question is population, so it will somehow create a standalone question like population of Japan. Okay, because this is a question that we want to answer. Okay, so capital of Japan, what a population of Japan. So whatever answer we will get, it will again write in the history, so that the next question will be based on this population of Japan as context. Because in the next one, this whole thing, tell me capital of Japan, capital of Japan is Tokyo, population of Japan, and the number, it will be all the things will be stored in the chat history DB or the memory. So that's why read and write to functionalities are there. Okay, I hope you will understand it. Okay, now let's see some code about it. Okay, like how we can do it. Okay, so let's see some code on basic memory in Langchain. So this is a very basic example of memory. So this is how we import a memory. So I am importing a conversation buffer memory. You can import anything. Okay, here you can see some files are there. So config, in config file, I am putting all my API keys. For this video, you don't need any API key, but in some case where I am seeing making some examples, so you need a LLM. So no need to use your OpenAI key. If you don't have OpenAI key, that's fine. You can use your Hugging Face API token. If you don't know about Hugging Face, it's like a GitHub for models, so you can use all the LLM models for free. Definitely not the closed one, but open source models like GPT-2 or some Google 25XXL, that kind of model you can definitely use. Mistral models. Okay, so you just need a Hugging Face API token, which is free to create. But if you have a OpenAI token, you can use OpenAI token also. Okay, so here it is our example. First is a very basic example of memory. So we are using conversation buffer memory. Don't worry about conversation buffer memory. We will see what is conversation buffer memory, but as of now I'm just using it. So first of all, I have created an object of it, and then memory.chat memory.add user message. So I am using user message, means which is human message, and then AI message WhatsApp. Okay, now I am printing the memory, so I am getting this conversion buffer, chat memory, chat message history. First message is human message, which is content high, and AI message, which is WhatsApp. Okay, so it's very easy. Okay, this is how we add user message and AI message. Okay, so this is very basic example of memory. Okay, so now what we can think is like here you can see like there can be a doubt in your mind that when building a memory system, two key design decisions need to be made, like how the state is stored, like, and how state is queried. Okay, this involves like if you talk about how state is stored, this involves determining the format and storage mechanism of maintaining a history of chat interactions. The Langchain memory module offers a range of integrations for storing chat messages, including in-memory list or persistent databases. How state is queried, so this involves the data structures and algorithm used to query the stored chat message. While storing a chat message is relatively straightforward, designing effective querying mechanism is more complex. Different systems may return different views of the chat message based on their specific requirements. Okay, now let's see how the chat message is basically stored. Underlying any memory system is a list of chat messages. Like there can be list, like first list can be human message, then can be AI message. Okay, Langchain provides integrations for working with chat messages, allowing developers to store messages in various ways, from simple lists to more complex data structures. Okay, we will see one by one. Now let's see how we can query a chat message. So querying a chat message involves extracting relevant information from the stored messages. A simple memory system might return the most recent message, while more advanced system might summarize the past message. We are going to see, because we have seen the like we have in the intro video, we have seen there was a video for conversation summary memory kind of. So in that case, the exact past message we will be not getting, but the summarized past message. Or we can also extract some entities. We will see also the entity memory part. Okay, Langchain supports various data structures and algorithm for querying chat messages, making it easy to implement both simple and custom memory system. Okay, so this was some theory part. Now definitely we are not going about theory part, but now we will be seeing some more code. Okay, so let me hide it. Okay, so the next one is variables returned by memory. So before a chain processes inputs, it reads various variables from memory. So these variables have specific names that must align with the variables the chain expects. You can determine these variables by calling memory.load variables. Okay, and you have to also pass an empty dictionary. We will be seeing it's just a placeholder for real variables. If the memory type you are using depends upon on input variables, you may need to pass some in. Okay, so here you can see like this is how we read the variables. Like here you can see in a very basic example of memory. So we have added two messages, hi and WhatsApp. Okay, now if I want to see all the variables, so what I will do, memory.load variables, and I'm passing a empty dictionary, which is a placeholder for real variables. So it will be now history, human, hi, and then AI, WhatsApp. Now can you tell me in which format the message is? It is in a string format. This is all history, like human, hi, AI. This is in a string format. Okay, we will be seeing, this is important, just note it. Now we are creating, now let's see, like okay, so okay, now here you can see, like in this example, load memory variables return a single key, which was history. This was the key for your dictionary. This means that whenever you have to use in your chain or in your prompt, you should accept an input name history. But you can control this variable through parameters on the memory class. For instance, if you want the memory class to return in the key called chat history, okay, then you can use the following. Like again, we have created a memory, and now instead of just defining the memory, we have also added a memory key. Okay, if we are not naming this memory, then it will be using this key history. But if we want chat history key, we have to make this like memory key chat history. Then again we are adding messages like hi and WhatsApp. And if we are loading the variables, now you can see the difference. Here the key was history, but here is the key is chat history. So in this way you can also control this name of memory key through the parameter. This is very important part, like how the memory format is stored. Is it in string or a list of messages? Showed you this one, like this history, and this was the message like human hi \n for new line AI WhatsApp. Here also human hi \n AI WhatsApp. So is it in a string format always? So this memory is stored in string format or in any other format also. So one common type of memory involves returning a list of chat messages. These messages can be returned in two formats. First one is single string. So this is how single string. So the messages are concatenated together into a single string. This format is useful when the message will be displayed into large language models. But second one is also list of chat messages. Each message is returned as a separate object in the list. This format is useful when the messages will be displayed into the chat models. By default, memory is returned in a single string. To return it as a list of messages, you can set a parameter which is called return messages. So here you can see, again we are creating a memory with a memory key name as chat history. We have just shown that why we are using a memory key. Then if you add a parameter return messages true, it means that now we want it in list. Okay, if you don't mention that, by default it will be in a string format as you have seen here. Okay, because we have not added this return messages equals to true. Now if you add a user message hi and AI message WhatsApp, and if we load the variables, now you can see we got a list. Okay, just see this part. Okay, so we got a list. Initially we were getting a string here. Okay, So this is also important. It's by default it's stored in a string format, but if you add a parameter which is return message is equal to true, then it will be storing into list of messages. Okay, that's it. Now keys save to memory, this is also a part which you should not worry a lot, but let me tell you, like in cases where chains take in or return multiple input and output key, it is important to specify which key should be saved to the chat message history. This can be controlled using input key and output key. Okay, you can add here input key and output key. Okay, on the memory types, but by default these parameters are set to none. So if there is only one input and output key, it is automatically used. Okay, however, this if there are multiple input and output keys, you must implicitly specify the name of which key to be used. Okay, you don't need to worry a lot about it. You can just add input and output keys here in the while making the memory, so that if there are different memories, if there is one memory where you want a different input and output key, you can mention it. So now let's see some example. Okay, whatever we have studied, how we can utilize it. Okay, so let's see example. So basically I'm not using this OpenAI, so let me remove it. Okay, we don't need it. Okay, so we are just using this prompt template to create some prompts, and we are using Langchain because we need a chain. Currently we are using conversation buffer memory, which is a very basic kind of memory. No need to worry about conversation buffer memory, we will be seeing in some videos, but this is a very basic memory. I'm using it because I'm going to use a LLM which is from Hugging Face, which is free. Then I'm using this config because my Hugging Face API token is in this config file, so that's why I'm using it. I can't show you the key. Then we are using it OS. Okay, so let me give it a run. Okay, so till it is running, so I'm calling this I'm setting this Hugging Face API token from the config. If you don't want this all things, you can just add your Hugging Face API token here in the string format. Then we are using this model from Hugging Face, which is Google Flynt 5XXL, as our SLM. Actually it is SLM, I think. Okay, and the temperature is 0.1. Now we are creating a memory which is conversation buffer memory and memory key. Why we are adding memory key? Because we want our own key for the memory. Okay, then we are adding a user message like hello, and AI message as hi, I am assistant, how are you? And I'm creating a template that you are a nice chatbot having a conversation with a human. So previous conversation, why we need this memory key. So here we are passing the memory key, and this memory key will be holding this two this two conversation. Actually it's one conversation, like from the user. First of all there will be user message, then there will be AI message, and this is one conversation. So it is having currently one conversation, and the new human question will be what we will be entering, and the response. Then we are making a prompt, simple prompt template, and we are passing this template. And then to see which kind of prompt it has created, so it is prompt.format. So here you can see there are two input variables. First one is this chat history, which will be coming from memory. Okay, because our memory key is this one. Okay, this should be same. Okay, then question, what the user will ask. Then your template, you have a nice chatbot having conversation with human, previous conversation, this one is the previous conversation, and this will be the new question. Now we have created a chain, because to run our prompt we need a chain. So LLM chain, so we are passing the model which is Hugging Face open source model, which is Google Flynt 5XXL. Then we are passing this prompt verbose true, because we want to see what is happening behind the scenes, and then memory is equals to memory. Okay, so let me also give it a run so that I can show you something in running. Okay, so let me also print the format. Okay, so this is how our conversation chain will be. LLM HF is not defined, so where we are defining, okay, sorry, so this cell was, I haven't run it. Okay, so just, okay, so I ran it. Now let's see. Okay, so we have created a chain. So let's see how our chain looks like. So memory is equal to conversation buffer memory chat, this one is the chat. Okay, it is already there. Okay, so here you can see, okay, human message hello, and hello, hi assistant, how are you, like this was the message. hello, hi, I'm an assistant, how are you? So it is already in the chain history. Okay, then memory keys chat history example, verbose is equals to true, and this is how our template will be looking. Okay, so you can just say it. Okay, so conversation chain question hi. Okay, so now I am asking another question which is hi. So here you can see, okay, definitely you should use invoke here. Okay, actually this type of calling has been depreciated, so let's call once. So here now see, this is the interesting part that I want to show you. Okay, so here it is giving like you are a nice chatbot having a conversation with a human, previous conversation. Okay, from where it is picking that previous conversation? From this memory, because we have passed the memory, and in this memory there is a key which is chat history example, and that history will be depicting from that memory variable. So that's why it is able to read the memory. So see, previous conversation, human is hello, AI, hi, I am an assistant, how are you? So now human is again asking hi, so what will be the response? Same, hello, I am an assistant, how are you? Okay, so now let's suppose let's begin some conversation. Question: what is USA? So let's see what the prompt has been created. Previous conversation. The first conversation, hello. So the AI assistant that we have fed, this one. This is the first conversation that we have already entered. Okay. So we have entered it. Hello. Hi, I am an assistant. How are you? So new human question was hi, and the response was hello, this one. Okay, so this was a new question, what is USA? So till now we have done two conversation. So this was the two conversation, hello, hi, I am assistant, how are you? Then hi, AI, hello. Okay, so I think they have took this one like hello. So in AI it just stored hello. Okay, now new human question is what is USA? In the response it is stored like United States of America. Okay, so now let's see what is actually happening. Who is the president of USA? So here you are a nice chatbot having a conversation with a human, and the previous question was hello, and AI said hi, I am assistant, how are you? Again hi, hello, and in human asked what is USA, so it answered United States of America. Okay, then we asked who is president of USA, so it gave the answer like Donald Trump. Okay, so let's see. Okay, so let me also run these things. Okay, then let's suppose we asked okay, here again we have to do invoke. Okay, so what is USA? So in history it is stored United States of America. Okay, so now I ask like who is president? Okay, so let's see what will be happening. So first it is storing hello, then hi, I am an assistant, how are you? Then hi, hello, I am an assistant, how are you? Then what is USA? United States of America. Then I'm asking who is president. Okay, so who is president? So now just observe that I haven't asked who is president of USA. It took from the memory that it might be talking about USA. So now the new human question was who is president. So it gave the response as Donald Trump because of the memory. Okay, because of the memory it was able to depict that okay, the user might be talking about the USA only. Okay, then if you load all the variables like memory dot load variables, all the variables will be there, so it's very easy. So here you can see all the variables are there like hello, then hi, I'm an assistant, how are you? Then hi, AI has stored hello, I'm an assistant, how are you? Here you can see all things are there like hello, I am an assistant, how are you? But when we were creating this prompt initially, here it stored all this thing, but somewhere I think we have seen that it only showed us the hello only. I don't know where, but hello, I am assistant, hi, and here hello, it's just still showing. I think just saw somewhere it was storing just it was just showing this hello world, hello word. Okay, that's fine. Okay, so it has stored all the AI message as well as human message. The last human message was like who is president, and AI has asked like Donald Trump. So now let's ask some more questions also. Like we were talking about the who is president, so it answered about Donald Trump. So let's see if we can get his age also. What is his age? What is his age? So from memory it should depict like we are talking about Donald Trump, and it should bring his age. Okay, so let's see. So again, we who is president? Donald Trump. What is his age? So it answered like, oh, Donald Trump is 70 years old. I don't know whether he is 70 years old or not, but it returned it like Donald Trump is 70 years old. Okay, so this is how memory works. Okay, so here you can see like every time we don't have to implicitly mention that in which topic we are talking about, because whenever we will be having conversation, so a new question should be related, may be related with the previous question. So the previous question should be stored in the memory. So that's why memory play a very important role in this modern chatbot. Okay, now we will be talking about chat messages. So typically you have seen we were using a chain to interact with and manage the memory in a chatbot project. Okay, a chain helps to orchestrate the flow of information, including reading from and writing to the memory. The chain process inputs, retrieve information from memory, perform actions based on that information, and then update the memory accordingly. For example, a chain might read a user input, retrieve relevant information from memory, use that information to generate a response, and then update the memory with any new information from the conversation. But you can use the chat message history class directly to manage the chat history outside of the chain also. This class provide convenience methods for saving and fetching human messages and AI messages. It can be useful when you need to manage a memory at a lower level or outside the context of a chain. So here you have seen that we are using LLM chain. Okay, and we are here whenever we were creating a chain, we were passing the memory. Okay, so here you can see like whenever we were creating a chain, so this was a place where we have created a chain, so we were passing a memory. But what if we want to store our memory outside the chain? Okay, maybe to some external DBs. So how you can perform it, like from langchain.memory import chat message history, you can create an object of it, and then history.add user message, history.add AI message. Okay, so you can like manage memory at a lower level outside the context of a chain also. And if you want to see the memory, just history.messages. So here you can see human message, content hi, AI message, content WhatsApp. So it can be also helpful in some scenarios. Okay, so that's why I have just mentioned you, but in the most case we pass it in this memory format only. But in memory also we can have some external DBs, like maybe you can use MongoDB for storing all of your chat history. Okay, but in application, if you want to use, we can use this memory, and the example that I have shown you, it can be very beneficial. So that's it for the introduction of memory. You can just clone this notebook and take a pull of it, and then just try to implement on your side and have some experiment on it, so that you can just run all this code and experiment a bit by adding your own memory and seeing what are the how we load the memory variables, and just play around it. Okay, and in the next video we are going to see the memory types, where we will be seeing, I think, around 8 videos on the memory type only. So I think you have enjoyed this video, and if you have learned something new, so please give us thumbs up and subscribe to our channel. And I hope we will be meeting in the next video. Till then, bye bye.